All right. We're good? Yours looks a lot better than mine does. All right. So greatest common factor. Make sure that in GCF you've been dealing with for a long time too, but always make sure that you're actually looking for the GCF and not just the CF. The CF would be the common factor. You want the greatest common factor. So when you look at number 1 here, I'm going to be able to factor something out. K is only on one of the terms, so I can't factor a K out. But what's the biggest number I could divide out of 12 and 18? 6. Very good. So I can factor out a 6. That would leave me with 2K minus what? 3. And then that's as factored as it gets. Right? And sometimes you can keep going. We're doing factoring day 1. Factoring day 1.
Oh.
I know. And I think sometimes the order will flip around, and I don't know why, and I don't know how to make it not do that. Okay. So let's look at number 2. Actually, you do number 2. Factor out the GCF in number 2. What are you doing? Are you being a problem child? Technology's wonderful, isn't it? So you should be working on number 2. Make sure you take out variables and numbers, not just numbers, if you can. Maybe we should do this one together? Yes? Okay. What's the largest number I can take out? 8. I can factor out an 8 because 40 and 64 are both divisible by 8. That's the biggest number they're both divisible by, so I'm going to take out an 8. Then I look at, I have x to the 8th and x to the 4th. So how many x's do they have in common? 4. So I can take out 4 of them, x to the 4th. And then how many y's do they each have in common? Just 1, so I can take out a y. So then that leaves me with, in that first term, a 5. I took out 4 of the x's, so I have 4 left. I took out all the y's, so I don't have any of those left. And then plus, what's my number? 8. Do I have any variables with it? Nope. That's it. And you can always double check yourself by saying, okay, if I do this, if I multiply it back, this times this times this, then am I going to get the exact same thing? The answer should be yes. Okay, we good? What do you have a question on?
No, I thought you meant like to move it.
Oh, okay. No. All right, then y'all do number 3 on your own. We'll do number 3 and then we'll move on. Good, Leo. Don't put an exponent on the 7. There's no exponent on the 7. Don't. You can use 7, but you don't put an exponent on the 7. You need a variable to have the exponent. Does that make sense? Okay. So with these 3 terms, what's the biggest number you can divide out of each one of them? Okay, so write down a 7. And then how many m's do they have in common? Like No, there's 6 here, 3 here, 2 here. So they all have at least 2, right? So you can take out 2 of the m's. So we have m squared out here. Okay, parentheses, and then see if you can figure out what's left. Okay. All right, so 7 is the biggest number I can take out. The largest amount of m's they have in common is 2, so m squared. That leaves me here with 2 times m to the what? 4th, minus what? 5m, right? Then do I close my parentheses? No, and that's one of the biggest mistakes that's made, because you took this whole thing out. It doesn't disappear, because I'd have to multiply it back in. Like, I still have to have 3 terms, so then this is minus what? 1. There you go. Okay. What questions do we have? We good? All right. So let's talk about a special case of factoring with difference of squares. All right, so there's a rule for this. This is what your difference of squares looks like. If I have something that looks like a squared minus b squared, this comes up a lot, and it is super easy. This just becomes a plus b times a minus b. All right, it's just a pattern. Happens every time. If both terms are perfect squares and they're being subtracted, you have a difference of squares. Okay? So when I look at number 21, x squared is a perfect square, 4 is a perfect square. So I can factor that into 2 binomials. I take the square root of the first term, so the square root of x squared is x. I take the square root of the second term. Square root of 4 is 2. So my answer is just x plus 2, x minus 2. That's it. It's factored. Okay? We good? It's almost like magic. What questions do you have? Why don't you try to do number 22? We'll do another one. But y'all try 22. Same pattern, same concept. Follow what just happened on the others. Good, Adrian Villarreal. Good, Daniel. Good, Leo. Where did you get that number from? And this should say a squared minus b squared right here, not plus. Take the square root of the first term, square root of the second term. Kevin, you're doing the same thing. Where are you getting that number from? You're getting this number from, the 2.
The 2 up here?
Well, the y came from the y squared. This number has to come from the 81. You have to take the square root. All right. Good, Manuel. Okay. Good, Adrian Reyes. All right. So I'm going to have binomials. The square root of y is y. The square root of 81 is 9. One's positive, one's negative. That's it. Done. Okay, does that make sense? All right, so let's talk about what happens when we have some variables in there, like on 23. Same thing. This is a perfect square, and this is a perfect square, except that mine kind of looks like a blob. Does this say 9x squared? Yeah, it does. Okay. 9x squared right there. So I can put this into 2 binomials. The square root of 9x squared is 3x. To take the square root of exponents, you just divide them in half. So then the square root of 25y to the 4th would be 25 what? Y squared. Good. So then this is 3x and 25y squared. One of them is positive, one of them is negative. You're done. So you do number 24.
Wouldn't the 25 be a 5?
Oh, yes. Thank you. Good Lord, y'all just let me move on. Yes, don't do what I... See, I was seeing if you were paying attention. I was so focused on the variable, I didn't pay attention. So yes, what I had was wrong. It is 5y squared. Thank you for stopping me before I just really looked dumb up here. And then 3x minus 5y squared. Maybe I should just let y'all do it yourself. I won't have my stupid mistakes in there. Okay, we good? All right, then you try 24 after I tried to confuse you. So on 24, the m squared n squared, when I divide those both in half, I get mn. The square root of 49 is 7, not 49. So I get mn plus 7, mn minus 7. And if you had the minus 1 first, it wouldn't matter. Like you could say mn minus 7 times mn plus 7, whatever. Okay. We good on difference of squares? Yes? No? Can we do one more? Yes, let's do this one. Well, actually, we're not going to do that one. We'll change this one. Let's just say that I'm going to change this to 16 y to the 6th minus 4x squared. Why don't y'all do that one? Now, just because you have two terms doesn't always mean it's a difference of squares, but these are. I just want to clarify on that. Okay. So I know they're plus and minus, right? And then I put the same things, the rest of the parentheses, everything's the same. The square root of 16 is 4. What's the square root of y to the 6th? Y cubed, good, because you just divide it in half. Square root of 4 is 2. Square root of x squared is x. So this would be 4y cubed minus 2x. Most of the ones that we are going to come across, not all, but most of them, that's why it's important, are going to look more like 21 and 22, where it's just a variable and a number, and it happens like a lot. But these other situations do come up as well, where we need to be able to make sure we work through that. Okay? Are we good on that? You feel a little bit better about it? Okay. All right, so we're going to skip the cube stuff for right now. So the next thing I want you to pull up, you're probably going to skip 2 slides. I think it might just be the last slide that, let me see. Oh, I can't actually see yours. But you're going to go to the one where you have the 2h cubed that's first. I'm not sure which one it is. I apologize. Did you find it, though? It is in there? Okay. All right, so we're going to factor these. And if you have 4 terms, we're going to go back to the trinomials tomorrow, but we have 4 terms, okay? The only option you have, if it's factorable, is to factor by grouping, okay? So I have 4 terms. Can't combine my like terms or anything. So I'm going to factor by grouping. What that means is I'm going to group these first 2 together and the second 2 together. Okay? Then out of each set, I'm going to factor out the GCF. And the way I write things down is important, so I don't get myself all mixed up with how things relate. Out of these 2, the GCF is what? Well, the number, yes, but what about the variables? H squared? Just out of those 2 terms, right? So I get h squared is factored out. That leaves me with 2h minus 3. That's just for the first ones, right? For the second 2 terms, What's the GCF? 3. So then this is a plus 3 that comes out, and that leaves me with 2h minus 3. So your goal, and what should happen and what did happen here, is that these two things in the parentheses are identical. You with me? Now I have two big terms, this whole thing plus this whole thing. So now the thing in parentheses is actually the GCF. So I'm going to factor that out and get 2h minus 3. Once those have been taken out, I'm left with h squared plus 3, and it's factored. That's my answer. Okay. What questions do you have? All right, so I want you to at least start this one that's z cubed. If I need to come in and help you figure out the rest in a second, I will. I'm trying to figure out which. There I am. It's on number 7. Oh, is that the next page? Are these on each on a separate page? Oh, okay. Sorry, I couldn't remember how they were split up. So remember to group them, factor out your GCFs, see if you can follow those same patterns, okay? Good job, Adrian V. Leo, you are on the right track. Manuel and Liz, are you? No, it's just slow up there, I think. I think sometimes it doesn't show me what you got. Are you totally stuck? Group the first two together and the second two. And then factor out the GCF in each little set. Where are you getting that from? You need to factor out the GCF in these two. So this one has 3 z's, this one has 2. So the most you can take out is 2. What does this say? 7z. Okay, well, you have to factor this out of just these first two. So this has to come from these two right here. Okay. All right, so out of these two, I would factor out a z squared. That would leave me with a z plus 7. Out of these two, I would factor out a negative 5. That leaves me with a z plus 7. Watch your signs there, right? Because if I factor out a negative 5 here, is just what I should do, then that means that this sign changes as well. So be careful with that. And, all right, so then I'm going to factor out that z plus 7. Once those are gone, then I'm left with z squared minus 5. Then if this was a difference of squares, I would go on to the next, I would keep factoring, but it's not so. I mean, because 5 is not a perfect square. But. Okay. What questions do we have? All right, let's do the next one then, that's 6r cubed. Unless you have questions. Ask me if you're not sure where something came from. Okay, let's do this one together. Oops. So I'm going to group these two together, group these two together. Out of the first two, my GCF is going to have numbers and variables in it. What's the number that gets to come out? 3. So 3 is going to come out, and how many r's? 2, so it's r squared. So then with these two, that leaves me with 2r minus 3. Right? So that's just factoring out of the first two terms. Then I look at the second two terms. What am I going to factor out of that? 5. So there's going to be a positive 5. That leaves me with 2r minus 3, which is what I would expect. I expect these two to be the same. Then you take that binomial, factor it out, 2r minus 3, and then you're left with the rest, which is 3r squared plus 5. And there you go. Okay. What questions do you have? We good? Explain it one more time? Walk through it? Okay. So this 3r squared, out of these two terms, this was the GCF I could factor out. Does that make sense? So from these two terms, this is what I'm left with, right? Then I move on to these two terms. The GCF here is 5. So I can factor that 5 out. That leaves me, once I divide it out, with 2r minus 3. You good? So now these two, like if I look at this as this one big term and one big term, they both have these parentheses in them. So I factor that out to the front. That's where that comes from. Once those are gone, then I'm left with 3r squared plus 5. And that's my second one there. Okay, does that help? Okay, good. You good? All right, so y'all try the last one on your own. Where's this 3 coming from? The GCF of these two numbers, 4 and 20? Four, yeah, 4 and 20 are both divisible by 4. Okay, you gotta be careful. Now, so what do you notice right here? What's making you go, But then, okay, very good. So that doesn't mean you're 100% wrong. So before you erase everything, the problem is in both of these, you didn't factor out the GCF, you just factored out the CF. So you factored out a common factor, but not the greatest one. Because look, these are both still divisible by 2, right? So you really could have pulled out a 4. And then these two are both divisible by 3, so you really could have pulled out a 9. Does that make sense? Yeah. So you're not wrong, it's just not completely factored out. But that's good that you were like, something's not right. Oh, Leo. Oh, okay. So I see why you did this. But this is not a difference of squares, and there's no such thing as a sum of squares. We have sum of cubes, but it only works for squares if it's difference. So then you have to stop there. Does that make sense? Okay, but good job thinking ahead like that. All right, let me walk through this one with you. So always make sure it's the greatest common factor. And if you notice something weird, like if you get to the point where these two don't match, that's when, don't just erase everything you have, because it doesn't mean you're 100% wrong. Figure out why, and maybe it's because you have more you could actually factor out. Okay, so out of these two, 4 and 20, I can both factor out a 4 and then a c squared. That leaves me with c plus 5. And then out of these two, I can factor out a 9. That leaves me with c plus 5. And sometimes you don't recognize the greatest number until you have factored something out, and then you realize you could factor more. Then I can factor out that c plus 5, and that leaves me with 4c squared plus 9. This looks like a difference of squares, but it's a sum of squares, and you can't factor those. You can only factor it if this was a subtraction. So that means I am stuck, I am done, I'm here. Okay? What questions do you have? Now, your assignment is in Delta Math, but it has stuff on it that we're going to do tomorrow and the next day. And I know on the calendar I put that it's due in 2 days. I might have put that in Delta Math as well. And I realized when I was saying this stuff at the beginning that I didn't mean to do that. So I'll go change the due dates. So what I'm saying is you could do the stuff that says difference of squares, and you could do GCF, and even some grouping, but maybe leave the other stuff until we talk about it tomorrow, okay? But the more you do now and kind of get ahead of it, the better off you're going to be, okay? What questions do we have? Are we good? All right, you got like 6 minutes left. Get out your Delta Math. Do something. You have something due today, right? Maybe? I get confused on I teach 2 different things now, so you gotta bear with me. I'm like, I don't remember which class I'm talking about. So just double check. See if you have anything you haven't completed that's due today, and then move on to the other, all right?